So the area of a rectangle, I'm just going to rewrite it because that's horrible. The area of a rectangle. So you guys are all going to zip your face. The area of a rectangle is 56 square inches. Okay. Write that down. The area of a rectangle is 56 square inches. The length is 2 more than 3 times the width. What are the dimensions? The area of a rectangle is 56 inches squared. The length is 2 more than 3 times the width. What are the dimensions? I'm going to do that in a second. We're going to draw a rectangle, but I want everyone to get the word problem written down first. So write it down first. So we have been solving, but really we've been factoring quadratics for quite some time. Someone tell me how you find the area of any shape. Well, that's volume. It's a product, right? It's usually the length times the width or the length times the height divided by 2 but usually like the area of a shape is typically a product, right? So I want you to think about what we've been doing. We've been taking a binomial and multiplying it by another binomial and getting a quadratic equation, right? So the idea of area really lends itself to quadratics. So that's really what we're going to kind of start focusing on as we start talking about like real world problems. So I'm going to draw a rectangle and I'm going to label the sides. Yes, you should, because it'll help make sense in your brain. So this is my width, which I'm going to call W. And this is my length, which I'm going to call L. And I know that the area, which is like the space inside the box, is 56 inches squared. So you could absolutely plug and chug, God bless you, and figure out what number this is just by looking at factors of 56. I have no doubt in my mind that you could do that. And this one is pretty easy because I didn't make it fractions. However, probably you might see some fractions in the near future with problems like this, right? So let's talk about what we said. I think that first sentence said the area of a rectangle is 56 square inches. And then it said the length is. What does that word is mean? Equals. So the length equals 2 more than, what does that mean? That would be twice. I'm going to add 2 to something, right? So 2 plus 2 more than 3 times the width. How do I show that? 3W. 3W, because the width is W. So if I let the width be W, and I'm just going to write it in red so you can see it, I know that I find the area by taking the length times the width, right? And we said that the area is what? 56 equals, what is my length? 2 plus 3W times my width. Now I know that is on the back side, but it's still a distribution problem, right? So that means that I have to take this W and multiply it by both terms inside of the parenthesis. So now I have 56 equals W times 2 is 2W, not W2. 2W, the number always goes first. It's called the what? Who said that? +1, coefficient. Yep. Do. It's called a coefficient. And W times 3W is 3W squared. Okay, so yesterday we learned that we could solve a quadratic equation if two things. Number one, it was written in standard form. And number two, it was set equal to 0. Okay, so let's do that. Let's write this in standard form and set it equal to 0. So the first thing that I'm going to do is fix this piece right over here. I'm going to put the 3W squared first plus 2W. So it's kind of in standard form. Now I have to set it equal to 0. How do I do that? I need it to say 0 equals or equals 0. Subtract 56. Yeah, from both sides, right? So now I have 0 equals 3W squared plus 2W minus 56. Okay, now get your brains ready. How do I solve this? We have to factor it, right? So I have to figure out what A times C is and what is B. Well, what is A times C? 3 times negative 56 is negative 168. Thank you. Has to add up to 2. So you need to find factors of negative 168 that when I combine them, add them together, I get a positive 2. So y equals negative 168 divided by x. Caitlin, you have it? 14 and negative 12. Awesome. 14, negative 12. 14 minus 12 is 2. 14 times negative 12 is 168. So I'm going to do both a factor box because some of you guys like the factor box. And I'm also going to factor by grouping. So factor box, 3W squared. And my last term, negative 56. The two factors I'm using, 14W and negative 12W. Factor by grouping, 3W squared plus 14W minus 12W minus 56. Okay, let's look for a GCF here. What's the greatest common factor between 3W squared and 14W? W, which just so happens to also be the greatest common factor here. So I'm going to take out a W. When I take out a W in the grouping, I'm left with 3W plus 14. What's the greatest common factor here? 56 isn't divisible by 12. 6. 56 is not divisible by 6. It's bigger than 2. It's not 3. 5 plus 6 is 11. 4. And it's got to be a negative 4, which just so happens to be the greatest common factor here. And when I take out a negative 4 here, I'm left with negative 12 divided by negative 4 is a positive 3W. Negative 56 divided by negative 4 is a positive 14. So I bet, this is just kind of to get you guys to see how factor by grouping and the factor box work hand in hand. So I bet you that the greatest common factor here is 3W. What is the greatest common factor in that first column? It's 3W. And I bet you the greatest common factor in this second column is 14. So do you see how it doesn't matter what method you use, you still end up with the same answer? W minus 4 times 3W minus 14 equals 0. So here's where we've had some like struggle, right? We learned yesterday that the zero product property says if two numbers get multiplied together and the product is 0, that means that either the first number equals 0 or the second number equals 0. That means that W minus 4 equals 0 or 3W minus 14 equals 0. Now we've had no problem with solving them when they look like this. Because W minus 4 equals 0, well, I add 4 to both sides and I find out that W has to be 4. And actually, Kane, I think it was you yesterday that was like, they're opposites. If you have a minus factor, you have a plus root. Wasn't that you yesterday that said that? Yeah, I think it was. I think you mumbled it. You might not have realized you said it. I don't know. I wrote on my notes that you were the one that said that. Someone did. Someone who sounds like Kane. The problem is when we get over here. Here's the problem. You look at this and you're like, oh my God, I don't know what to do. How did I get a negative 14? Do you see how? Oh, that should be a positive 14. Sorry, plus 14. Yeah, should have yelled at me. Yep. Perfect. Plus 14. Okay. So how do I solve this right here? This is where we struggle.
I thought out of one of the equations we did for homework yesterday, wasn't it just going to be 14 over 3?
Well, let's talk about how we did that. How do I solve this? This is a two-step equation. Subtract 14 from both sides. So 3W equals negative 14. And then we do what? Divide both sides by 3. So W equals negative 14 over 3. So here is the pickle. How many times have you looked at a rectangle and noticed that it had a negative side measure? Never, because that would mean it's like stuck in a black hole, right? It's not possible. So of these two answers that you have here, this one is called, well, it just doesn't work. It doesn't work in the real world. We call it extraneous, but it just doesn't work. Why? Because you cannot have a negative measure when we're talking about the actual real life measure of a side. So it means that the width of my rectangle is 4. Well, if the width is 4, then the length, let's see, well, we said that the length was 2 more than 3 times the width. So that means that my length is 2 plus 3 times 4, or my length is 14 inches. And if I wanted to check it, I could just take 4 times 14 and it better equal what, Jack? Open your eyes. You don't have the words on the back of your eyelids, I promise. 4 times 14 is, what's 56? It better be, right? Our area, otherwise we're in trouble. We did something wrong. Okay? So it's really important to understand why quadratics are important. And I know that you guys all the time are like, Mrs. Bischoff, I'm never going to use this again in my whole life. This is craziness. And I'm going to say to you, probably you won't. However, there may be a time that you need to calculate the area of something or calculate the most, like the maximum area of something, the maximum area possible, which the maximum happens at the vertex. You'll remember that come next week. And so calculating, knowing how to use a quadratic helps you maximize your profit, right? So quadratics are something that people use in all types of businesses if they want to maximize anything. Maximize profit, maximize square footage, maximize whatever. Okay. So we're going to go back